The history of 3D printing starts in the 80s, when it was called rapid prototyping technologies. It was originally designed as a fast and cheap way to create prototypes for product development. From there, it was expanded into the large and lucrative business it is today. The first patent in the industry was in 1986 for a stereolithography apparatus, which is owned by Charles Hull. Hull is a founder of 3D Systems Corporation, which today is one of the largest and most prolific organizations in 3D printing. Stereolithography's fundamental idea is to digitally design 3D models and turn them into physical objects. It uses an acrylic-based material called photopolymer, because if a container of photopolymer comes into contact with a UV beam, it will instantly turn solid, meaning if the photopolymer is poured into the right shape, it can quickly be solidified into the prototype. Stereolithography took off because it allows prototyping without large financial costs in manufacturing. It does, however, have some problems. There can be warping in material during hardening and is expensive for home use. The first rapid prototyping device to be sold commercially was the SLA-1, which first hit the market in 1988 and is pictured in the middle of the screen to the left of the old monitor. As the SLA-1 was being produced, 3 other inventors were working on 3D printers. The first was Carl Deckard, who worked with the University of Texas and filed a patent for selective laser sintering. His work was later acquired by 3D Systems. The second was Scott Crump, who founded Stratasys Inc. and filed a patent for fused deposition modeling. Finally, there was Hans Langer, who focused on the laser sintering process and produced the stereo system in 1990. Of the research conducted by the 3, fused deposition modeling was the most successful and is used the most today. It is divided into a 3-part process. Part 1 is called pre-processing, which is followed by production, and finally there is post-processing. Pre-processing is when software converts a CAD file to design a path to extrude thermoplastic and supports. After that, in production, the printer heats the plastic until it begins to melt and places it along the determined path. And to end the printing in post-processing, the consumer breaks off supports. The 90s also saw 3D printing lead to breakthroughs in the medical field. In 1999, the first 3D printed organ was used. Wake Forest Institute for Regenerative Medicine 3D printed scaffolds to support a patient's bladder. They then coated the part in the patient's cells, meaning the immune system would not reject the printed parts because it detected the scaffolds as part of the patient. Within 10 years, scientists had 3D printed a mini kidney, a prosthetic leg, and even blood vessels. The work of Deckard, Crump, and Langer in the 90s led to companies rededicating themselves to either high-end products designed for complex parts in the aerospace, automotive, medical, and jewelry industries, or lower-end concept modelers, which focused on being easy to use and cheaper. The lower-end models caused a battle for lower prices along with improvements in accuracy, speed, and material quality. The challenge to bring 3D printing to the average consumer was met with the RepRap project, which was founded by Adrian Bowyer in 2005. RepRap was open source and intended to design a printer that could print its own parts. The solution was Darwin, which launched in 2008 and is shown in the video. Because it could print its own parts, once Darwin was purchased, infinitely more could be created by the initial Darwin, and at only the cost of the materials. On the higher-end scale, 1 year after RepRap was founded, the company Objet made a printer that could print in different materials, which allowed producers to evaluate the different material properties of their prototypes. Despite improvements to higher-end 3D printing, the largest support came for the cheaper alternatives, and in response, Shapeways was created. Shapeways is a 3D printing marketplace where designers can post projects and allow consumers and designers to review it. MakerBot was also created and focused on making affordable 3D printers, as well as giving consumers access to open source do-it-yourself kits. The kits allowed consumers to build their own 3D printers. Today, 3D printers are vastly different from the machines from the founding of 3D Systems, Stratasys, and even MakerBot. They are smaller, faster, cheaper, and some can even print in silver or gold. Prices of 3D printers have also dropped dramatically. In the mid-2000s, the cheapest printers were $20,000. 5 years ago, the cheapest printers were $1,000. Today, a good printer can be purchased for a few $100s. 3D printers can also print much smaller and more accurate objects. The Photonic Professional GT can print objects as small as human hair and with this development, 3D printing can explore micro and nano structures. Today, there are even 3D pens, which extrude plastic instead of ink. One of these pens have even been used to make a working drone. The use of 3D printers has also expanded, as they've been used to make an unmanned aircraft, the body of a car that can get up 200 miles per gallon, and in 2012, a 3D printer was used to make a prosthetic jaw, which was used to counteract chronic bone infection. In Russia, 3D printers are even being used to make houses to avoid working during the harsh winters. .3D printers will also play a large part in the future. NASA is attempting to develop technology to 3D print food, thereby reducing the resources and time necessary to make food while on a long journey. The initiative is currently in phase 1 of testing, and NASA is investing $125,000. 3D printing is already being experimented with in space, as a small 3D printer was taken into space on SpaceX 4. The printer was part of the 3D printing in zero-G technology demonstration and is the size of a microwave, yet will produce objects of the same strength as a regular 3D printer on Earth. 3D printing has grown rapidly over the past 3 decades and looks to have a promising future. The industry has had a large effect on the way we live now, so much so that some are calling it the second industrial revolution.